Imagine you wake up tomorrow and the world's biggest supplier of one essential ingredient just turns it off. Electric car factories stall. Wind turbines sit half-built. F-35 jets can't get the parts they need. Not because we ran out of metal, but because one country on the other side of the planet decided to close the tap. Today, that tap is controlled mostly by China. And the ingredient? Rare earth elements, the minerals nobody talks about that quietly power the 21st century. The race is on. Can 3 projects in Greenland, California, and your old e-waste pile break this chokehold in time? Because if they don't, the rare earth crisis of 2026 won't just be a policy problem, it'll be the weakest link in the entire green transition. This is the Green Blueprint, and today we're diving into the rare earth crisis of 2026, part of our Global Project series. How rare earths secretly run modern life. Look around you, your phone, your laptop, your earbuds, your car, maybe even the wind farm on your horizon, all secretly depend on a tiny group of elements with very un-YouTube-friendly names. Neodymium, dysprosium, terbium, yttrium. If the periodic table had a popularity contest, these would be the awkward kids in the back row. And yet, they're the ones doing the heavy lifting. In your phone, rare earths sit inside the tiny magnets that make your speaker and vibration motor work. In an electric car, they're inside the powerful permanent magnets that make the motor efficient. In a wind turbine, they help the generator squeeze out maximum power with minimum size. They're in MRI machines, lasers, fiber optic cables, precision-guided missiles, radar systems. If modern tech had a credit sequence, rare earths would be buried deep in the special thanks section. Here's the twist. Rare earths are not actually that rare in the Earth's crust. What's rare is the ability to mine, separate, and refine them cheaply, at scale, without wrecking the environment or your balance sheet. And over the last few decades, one country quietly became the undisputed heavyweight champion of that game: China. Today, China processes around 90% of the world's rare earths and dominates the production of the magnets made from them. That was tolerable when trade was cooperative. It became existential when Beijing realized rare earths weren't just a business. They were leverage. For years, the rest of the world liked the cheap prices and looked the other way. Outsourcing the dirty chemistry to somebody else felt convenient. And then, in 2010, the world got its first jump scare. After a territorial dispute with Japan, Chinese rare earth exports suddenly plunged. Prices spiked. Japanese manufacturers panicked. It was a preview of what happens when a strategic resource becomes a diplomatic pressure point. Fast forward to the 2020s. The green transition explodes. More EVs, more wind turbines, more batteries. Meanwhile, tensions between China and the US, the EU, and others get hotter. Now imagine that same leverage, but at 2025 demand levels. This isn't just a US problem. Europe's offshore wind farms, Japan and South Korea's electronics industries, India's growing EV market. They all lean on rare earth supply chains that run through China. And the environmental story is messy too. Separating rare earths often means digging huge amounts of rock, using acids, and generating toxic waste. China accepted that environmental cost in regions like Inner Mongolia, where local communities have paid the price. So the world fell into a comfortable but dangerous pattern. Let China do the dirty, complex processing. ship the shiny finished gadgets back. And then 2025 hits, and suddenly everyone wakes up to the same question. What happens if this supply chain that we assumed would always be there becomes a geopolitical weapon, right in the middle of the climate transition? So what are we doing about it? Let's look at 3 big bets that could change the game. Tan breeze in Greenland, mountain pass in the US, and the global race to recycle e-waste. First, Greenland. Under these glaciers and rocky hills lies one of the world's largest deposits of rare earths, especially heavy rare earths like dysprosium and terbium, which are crucial for high-performance magnets. One of the most talked about projects is Tan breeze. If it reaches full production by around 2027 or 2028, it could become a major non-Chinese source of these heavy elements. But Tan breeze isn't just a mining story. It sits right at the crossroads of 3 forces. Climate change is making Greenland more accessible. Mining could bring jobs and strategic independence, but it also risks damaging fragile Arctic ecosystems and impacting indigenous communities. So, Greenland's rare earths come with a question. Can we build a mine that helps decarbonize the world without sacrificing the environment and people right where it's dug up? Tan breeze is a test case the whole planet is watching, and Greenland is just one example. Other regions will face the same climate versus resources versus geopolitics dilemma. Second, California's Mountain Pass. Once the world's main rare earth mine, it declined as Chinese production rose. Now it's back, run by MP Materials, and expanding with US government support. The goal? Not just mining ore, but building domestic processing and magnet manufacturing. So it's not just dig in the US, ship to China for refining, buy back the finished product. If Mountain Pass can close that loop, it becomes a template. Take one weak link in the chain and rebuild it closer to home. But remember, that template is needed not just in America. Japan, Europe, Australia, and others are racing to do their own versions so that no single country controls the bottleneck. Third, recycling. Right now, most rare earths in old phones, hard drives, and wind turbines are never recovered. They end up in drawers, landfills, or shredded for scrap. But new technologies are trying to change that, using better magnets-to-magnets recycling, advanced chemistry, even robots that strip out tiny components. If recycling can scale in the next 12 to 36 months, it won't replace mining, but it can slash how much new material we need and give countries a domestic urban mine that China can't control. In other words, your old smartphone becomes part of national security infrastructure. Here's the uncomfortable timeline. If projects like Tan breeze, Mountain Pass expansions, and large-scale recycling all hit their targets, global dependence on Chinese processing could drop significantly by 2028 to 2030. But if any of them stall because of permitting delays, protests, capital drying up, or technical failures, China's grip on the bottleneck stays strong for years longer. And remember, other players are moving too. Australia's Linus, EU projects, Japan and South Korea's recycling programs. This is becoming a global scramble to redesign a supply chain that most people still don't know exists. So let's go back to that factory floor we froze at the start. Whether those robotic arms keep moving smoothly in the 2030s doesn't just depend on clever engineers or climate policy. It depends on mines in Greenland, refineries in deserts, recycling plants for your old gadgets, and a web of international agreements that keep the tap open. The story of rare earths is really a story about how industrial policy, geopolitics, and innovation collide to define power in the 21st century. And the next few years are the plot twist. If you want to keep following the global projects that are quietly deciding what kind of future we get, hit subscribe and follow us on Instagram at thegreenblueprint_TGB. Thanks for watching, and as always, stay green, stay healthy, stay informed. See you next week.